Okay, let's look at the next example using some of our fundamental identities. We get some clues, and then from those clues, we need to be able to find all values of trigonometric functions, all 6 of them. So they give us one of them, and the sine of theta, 1/3. And then they also tell us that the cosine of theta is less than 0. Okay, so we're going to take this identity that says the sine squared of theta plus the cosine squared of theta equals 1. Remember that Pythagorean identity, first one. Okay, so we're going to take and square the sine theta and know that cosine squared of theta goes here. And then if I add them together, I get 1. So this is just 1/9 plus cosine squared theta equals 1. So I'm going to subtract the 1/9 from both sides. Okay, so now we understand that cosine squared of theta is equal to 1 minus 1/9. So that's going to be 9/9 minus 1/9. So that's 8/9. So if cosine squared theta equals 8/9, then I know that the cosine of theta is equal to plus or minus square root of 8/9. Okay, so remember this is the square root of 8 over the square root of 9. If you simplify the square root of 8, you'll get 2 times the square root of 2, and the square root of 9 is 3. Okay, so they gave us the clue that the cosine of theta is less than 0. So of our options for positive and negative, we're going to take the negative because that's told. So we've got the sine of theta equals 1/3, and the cosine of theta equals -2 square root of 2 over 3. Okay, now we have to find the remaining. So we're going to use the fact that the tangent of theta is equal to the sine of theta over the cosine of theta. So this is going to be equal to sine of theta 1/3 over the cosine of theta, which is -2 square root of 2 over 3. Okay, so when I flip these and multiply, I get -3 over 6. Let me do this a little more detail here. So I'm going to take 1/3 times 3 over 2 times the square root of 2. Okay, and it's a negative because the denominator is negative and the numerator is positive. So it's going to retain the negative. The 3's are going to divide out. So I have a -1 over 2 times the square root of 2. Now I'm going to rationalize that with the square root of 2 over the square root of 2, my friendly 1. So that becomes negative square root of 2 over 2 times square root of 2 times the square root of 2, which is another 2. So it's going to be tangent theta equals negative square root of 2 over 4. Okay, so we've got the 3 of them. All right, we need a couple more. Few more, 3 more. So we also want the secant, and that's equal to 1 over the cosine. So if I put 1 over the cosine, it's going to flip those, so it'll become -3 over 2 times the square root of 2. Multiply that, rationalize. we're going to get 3 times the square root of 2. It's negative. Negative 3 times the square root of 2 over 4. And then our cosecant is equal to 1 over the sine. So if we just flip the sign, this is not going to be much work since the sine was 1/3. Flip that and we get a 3. So we've got the secant, cosecant. The only thing that's left is the cotangent. And if we look at what the tangent was here, before I rationalized it, I can flip that, right? Okay, I multiplied it by this so we could rationalize the denominator. But if I'm going to flip it, then that radical is going to be on the top. So I'll just take the pre-rationalized answer for the tangent, and I'm going to know that flip that makes my cotangent. Hope that's okay with y'all. So cotangent theta equals negative 2 times the square root of 2 over 1. So we'll just leave it like that. All right, so we've got all 6 functions built. Just from that information. Sine, cosine, tangent, secant, cosecant, cotangent. Okay, let's look at a new situation here. We're going to have a tangent of theta that's equal to the square root of 3 over 3. But they're also going to tell us that the sine of theta is less than 0. And we derive the sine from the y coordinate. And if y is less than 0, and we build the tangent using the sine of theta divided by the cosine of theta. Ultimately, this tells us that the only way for the tangent to be square root of 3 over 3 and positive is if both the sine and the cosine are negative. So here's some other things we know from this situation. The cosine of theta is also less than 0. And remember that the cosine is paired up with the secant. So the secant of theta is also less than 0. And the cotangent is going to be the inverse of the tangent. And we already see that that's positive. So the cotangent is also going to be positive. In fact, let's go ahead and sort out the cotangent now, because we know that that's just going to be 3 over the square root of 3. And then my only work is to rationalize the denominator. So I end up with 3 times the square root of 3 on top. And then when I take the square root of 3 times the square root of 3, I get 3. And then 3 divides into 3. So our cotangent is going to simply be the square root of 3. Okay, now to get these other ones, we're going to use an identity. So they've given us the tangent. So let's look for an identity that's using the tangent. Okay, the tangent squared of theta plus 1 equals the secant squared of theta. Let's go get secant, because we'll substitute that for our tangent. Okay, so substituting square root of 3 over 3. Okay, so this is going to become, when I square that square root of 3, it'll be a 3. And then down here I square it, and it's going to be a 9. So 3/9 plus 1 is our secant squared of theta. And so I can reduce 3/9 to 1/3. So I'm going to come up here and write this as 1/3 plus 1 equals secant square of theta. All right, so to add 1, we're going to add 3 over 3. So this becomes 4/3. Okay, so our secant square of theta is equal to 4/3. Let's just write that down. And I'll put this on the left-hand side. All right, and so since the secant squared theta equals 4/3, the secant of theta is equal to plus or minus the square root of 4/3. So secant of theta is equal to plus or minus the square root of 4 over the square root of 3. And we're going to need to rationalize the denominator, but we can take a 2 out here on top. So this is equal to plus or minus 2 over square root of 3. So I'm going to rationalize that with a well-chosen one. So I'm going to put negative 2 square root of 3, and the square root of 3 times square root of 3 is 3. And I picked the negative one. So why did I pick the negative one? The reason I picked the negative one is because from the beginning, they told us that the tangent, which consists of the sine of theta over the cosine of theta, and the sine is less than 0. So for the tangent to be positive, it either has to be in this first quadrant or the third one. But since they told us the sine is negative, that forces the cosine to be negative because both the x and the y are negative here. So since the secant is 1 over the cosine, we know that the cosine was negative. That's going to make the secant negative. Okay, so now that we've got both the tangent that was given to us and we found the secant from this information we have, we want to go ahead and find the rest of these. Now there's a relationship between the secant and the cosine. They're inversely related, so the cosine of theta is going to be the inverse of the secant of theta. So I could flip this down here, but then I'd end up with a radical in the denominator again. It'd be a little better off if I went back up to my calculation of the secant and said, hey, since I'm going to flip that, it'll have the radical on top, and that's what the secant is. So let's write this as a negative square root of 3 over 2. So now we have the tangent, the secant, and the cosine. Of course, we want to get the sine and the cosecant. Okay, let's continue with something that can help us find the sine of theta. So we look at our identities, we can see that a tangent of theta is equal to a sine of theta over a cosine of theta. And whenever you have two parts, and you can find two parts are known, if you have three parts and you know two, you can find the other. So let's plug in the tangent, which we found to be the square root of 3 over 3, or they gave it to us. And then we found the cosine, but we don't yet know the sine. We found the cosine to be negative square root of 3 over 2. Okay, so at this point, if I want to multiply both sides by this denominator here, then I'm going to get negative square root of 3 over 2. And then here I have to multiply as well by negative square root of 3 over 2. Okay, now of course, if I multiply on top, same thing I have on bottom, it becomes a positive 1. So I'm going to put sine theta over here on this side, and we're going to say that the sine of theta is equal to, so I'm taking a negative square root of 3 times the square root of 3, so that's going to be negative 3 over 2 times 3 to the 6. So our sine of theta turns out to be negative 1/2. Okay, the last piece we have to find is the cosecant, which is related to the sine. So we'll come over here and we have the cosecant of theta is equal to 1 over negative 1/2. So that's going to be a negative 2. All right, so from that information, we're ultimately able to use our identities and find all of the rest.